Hello everyone, this is a little project for a motor driver that follows the sun, basically a solar tracker. You'll see many of them made with an Arduino or, an Arduino and servos that demonstrate the principle. Basically, have I got that turned on? Turn it off. Yeah, basically you have two sensors. Well, for each axis, each axis. So I'm only doing one axis at the moment. If you need two axes, then you just double all this up. Or I'm going to make it into a PCB, so it would be two boards for two axes and one board for one axis. So it's just one axis I'm doing at the moment. And what you have is you have two light sensors. These are just light dependent resistors. The more light that shines on them, I think it reduces the resistance. Yes, yes. If I put my finger over it, you get 10 kilo ohms, and then if you let go, then depending on how much light shines on them, it gives a different resistance. Yes, and you separate the two with a shutter. So if the sun's just shining in this direction, only the light will shine on this one. And then if the sun's shining on this one, if the sun's in this direction, the sun will shine on there. And the idea is we have a little motor. This is a DC motor, so I'm not using servos. So with this, because I'm using relays, you can build something really big, and you can put some really beefy DC motor on it. I recommend gearing, of course, because obviously a motor spins fast and you don't want this to spin so fast. So for this demonstration, I'm just using one of these little N20s with the gearing on the end. It's a 6-volt motor, but I'm running 5 volts at the moment. But anyway, it will turn it for the demonstration. But because we're using relays, these relays will take 10 amps, it says. That's what it says on them, 10 amps. So you could put a nice beefy 30 volt 10 amp motor on your project, and it will control that basically. So anyways, I'll just put that down there, and these are the two relays. Now the relays I'm using are these things. I don't know if you see them. Anyway, let me get my other let me get my microscope so we can view on top of that. Where is it? Ah, there. Oh, and by the way, this little application I made here for using with me. Hang on, let's get. Is it in shot? Move it over there. Yeah, I using this little microscope. It's a USB microscope, or you could use a USB webcam. It will show webcams. And yeah, I've put this on. Hang on, where's me? You know me, I forget things. Right, hang on. Let me just get my web page. Yes. So this is my normal web page, and let's just make that big. And you can see now I've put a Microsoft Store on there. So now I've got a Microsoft Store, and I've put this one on Microsoft Store, so you can download it from there basically. You just click on it, and then you just I've got you can view it in the your Store app. So if you just click it on there, it brings up Microsoft Store app there, and you can just get. I mean, I have it installed because I'm the developer, so it'll only give me an error if I try and get it. So anyways, yeah, right, so we'll go back to, let me just get rid of that. Yep. Yes. So this little app, basically, you just whatever you got plugged in, you just choose what you've got plugged in. Its resolution. I use me little thing for. Oh, I digress. I'm moving on with this. Hang on. Yeah, just double click for open it up. So I was just going to show. Yeah, show what's written on top of here. Get it in the right direction. Let's get it the right way up. Hang on out. Yeah, there we go. So yes, it says 10 amps. Well, it says 10 amps all round. Okay, I can hold my hand still. 10 amps for 250 VAC, 10 amps for 30 volts DC, and then it says 10 amps 28 volts DC, and 10 amps 20. So I reckon that should be different. So let's get rid of that. And let's bring my web page back. There we go. This is what it is. And if you look, can we just zoom in on that? I don't know. I don't know if you can see on there. I think it should be 7 amps. So I've probably got one. That makes more sense. But anyways, let's just go full width again. No, go that way. Yeah, that looks more like what it should be looking like. Anyways, so that's the relays I'm using, and what I've done is the relays are wired up like a bit like a half bridge. Each one's got a normally open and normally closed, and what you do is you put the power to the normally open. So I've got the red one there to the normally open. The common ones from each relay go to the motor. So we've got the green going to the motor, which is the common one in the middle, and then we've got that blue one there going to the motor, which is the common in the middle, and then the normally closed is the ground. So it's the negative, so the negative on both go to ground. They're both the same, and depending which relay activates, it gets switched to the positive. And so the positive, if this one's activated, it will send the positive down the blue line. If this one's activated, it'll send the positive down the green line. And if you remember, when they're normally when they in the normal state, they're both connected to the ground. So so when this is activated, this is still on the ground, and then that goes to the positive, and vice versa, basically. So you can basically with this module you can stick some really beefy motors on your project. And we're not using an Arduino. I'm using just a operational amplifier, op-amp. This little chip here. Let me just see. It only requires this little chip. It doesn't require this one, but I'll explain this one, why I've put this one on. This one is an OR gate. There's 4 of them on there. I only use 3, but I'll go through that. But if you really want to be simple, a simple circuit, this is the only chip you need, which is an operational amplifier. So let's just have a look at that. Where are we? Yes. Bring back my web page again. Let's make that big. Yeah, it's this one. It's this one here. So it's this one. So there's 2 op amps on there. So one is for one relay, and the other is for the other relay. And we got the 2 inputs as normal, and then you have an output. So what we have connected to the inputs is the well, let's have a look at the circuit. So just bring up the circuit. Here's the circuit, and let's make it big again. So here we are. These are the two LDRs, like dependent resistors. So we've got, that's one and that's another. I've put this jumper here, solder jumper. So these are actually on the PCB, but you can have some remote ones which I've put on this socket here. So we can have this input and that input from one LDR, and that's from another LDR, and they'll do the same as them. So if you're using the inputs, some remote ones that are plugged into the socket, then you don't want these two connected. But if you want to use the ones that are on board the PCB, then you connect these two. And so the signal comes in onto the positive side of the let's put a box around them. See what? So this is our op amp. Hang on, did that wrong. This is our op amp. There's two inside. This is so I say that the blue box is our chip. We've got our ground and our VCC coming in, and then we've got our two inputs with our positive. So from the light dependent resistor comes in. As this resistance change, basically what we've got is we have these two resistors which are both 10k, and that halves the voltage in on the negative inputs, and that gives us our reference voltage, which will, because these two resistors are the same, these two inputs here will be, I'm using 5 volts, so we're halving it, so this will be 2.5 volts coming in here and 2.5 volts coming in here. And then we have the same divider, the same voltage divider here, which using this LDR resistor and another 10k. So if this is giving us our full resistance, which will be 10k again, we have the same voltage coming in here, so that equals so that them two will be equal. And then we have another voltage divider here using the other LDR and that resistor, and that'll be doing this input, and it'll keep it the same. But when the light changes on this one, it will alter this voltage on here. Hang on, when this one changes, it will alter this voltage on this line, and obviously it'll switch this on. And then when this the light on this LDR changes, it will alter this input, and this one will change and turn it on, because this is a constant voltage. So that's how it works, and then all you have to do is all you need to do is connect that line to one zoom out one relay via a transistor, of course, and then this one to the other relay via a transistor, of course. They were on the modules. Well, let's have a look. Oh, let's bring me little magnifying glass out again. Let me just get that. Yeah, let's just bring that in to about there so we can see what I'm looking at. And if we look on this module there, where are we? There it is. There, you can see that little tiny transistor, that J3Y. That's the little transistor. Let's move that. Let's get back. Yeah, to circuit. But there will be like a truth table coming out of this, that one and that one. So if these two are the same resistance as this one and this one, this will be zero. So we'll have two zeros here, which with two off states, which is fine, because that way the relays are not energized. And well, I've just clicked then. I always get a blocked nose when I'm doing these. Right, yeah, so yes. And then if one energizes, this will come on, and while the other one's off. And then when the other one energizes, the other one will come on while the other's off. But at night time, when there's no light at all, and these are both in the resistance state, these can be both on. So if they're both on, we have the two relays on. It won't matter, it won't turn the motors, because if they're both on, they're both connected to the positive side. So if your two terminals of your motor are connected to positive, then it's not going to run, because there's no flow of current. There's no potential difference. But we have the coils in the motors energized, and that's using current. And really, I don't want that. You know, our motor's not moving. Yet we're using current power. If our power's limited, I don't want them turned on in that state. So what I've done is I have. Oh, let's just delete that. I have the NAND gate. The NOR gate. So I'm using a quad 2-input NOR gate. I'm only using the 3. The one I'm not using, the inputs gets taken to ground, because otherwise you end up with a floating output here. But the output's not connected because I'm not using it. So we've got the 3 NOR gates, and so what we do with the NOR gates, because basically what I want to do is, if both states of these are on, I want the outputs to be off. I only want the outputs to be on if one of these outputs is on. So if this output's on, then I want this output on. If this output's on, I want this output on. But if both outputs are on, I'll just say that if both outputs are off, then I want both outputs off. But if, like I said, if both outputs are on, I don't want to turn the relays on, because it's just wasting power, basically. So if both these are on, then I want this output to be off on both. So if we get this situation at night time, during the night, then where these are going to be both on, then these two I want to be off. So I'm using this for the 3 of these NOR gates. So basically, the output of the 1 amp, it goes in to one side, and the output of the other goes into one of the outputs of the other side. Then we have the output going into one of the second gates, and the output of the other going into the other of the gates. And then we have the output of this one going to both the last 2 gates. So basically how it works is, if these 2 are on, they're going in, we've got a 0 coming out here, so this is 0. And if this is, like I said, both these are on, so we end up here, we end up with a 0 here coming into these 2 points, but we've got a high on these two, which will give me no output because they're not matching. And this is inverted, of course. Have I just lost myself there? Yes, that's right. Oh, hang on, I've got it the wrong way. If the light is, yeah, right. If I've got my sun the wrong way around. These will both be high if. No, one will be low if it's night time. The night time will be low, so we end up with not a zero here. So if we end up with a zero there, we end up with a positive here. And then if we've got a zero and a positive, we've got. Oh. I've just lost it. Yeah. Anyway, that's how it's wired up. I forgot it. I can't remember whether it's on. The resistance is. This is on. Anyway, let's have a look. We'll see. We can check this. Right. That's. Yes. We're going to check this because we're going to. And this gives me an excuse to use my other application. So what I'm going to do is range. No, I'm just setting up my meter. Right, yes, it's a good excuse to use my other application I've written when I find it. Yeah, there it is. Yes, so let's connect. So this is my multimeter. Yep, there it is, and we're on auto. Well, we're on not far as far. Range. No, select. There we go. Ohms. That's what we want, and we want. No, I don't. I want voltage. Right, I've changed the voltage, and we're on DC, and let's just put a range in there. Okay, well, my thing just crashed there. I'll have to look into that. Never happened before. Connect. Why isn't that connecting? Very well. There we go, we're connected. And I'm on voltage. Range, right, I don't want millivolts, we want volts, don't we? There we go. Right, I'm only going up to 5 volts. Right, let me get my probes. Oh, yeah, I bought these new set of leads. Let me just get... It has these things. Brilliant, I love them. And what I can do is I can remove one of these caps like that. Then I can stick one of these in there like that. And then I can just stick that onto a negative somewhere. Try this one. There we go, that's that one. And then we'll just use our probe. Alright, this motor's going to go pissing around all over the place. Right, so what we got there? Hang on, let that spin round. I'll put my finger over it. my voltage divider. I need my glasses. Where are we? Oh, where did that come from? That's just popped out. I hope it was. Oh, where did that come from? Maybe it was that one. I hope it was. Maybe that's the one I want to connect to. Yeah, right, so is there we go. Right, these two yellow ones. That white one. Right, want to come out of these things. Right, I'm gonna take that off, stick that on, put the end of that put it on the end of that and stick that, I think it's this one here. No, it can't because I've got no voltage there. That's my voltage divider. Oh, right, it's that one. Is it that one? Yeah, that's connected to that. One of these two. Oh, it'd help if I had it turned on, wouldn't it? Yeah, there we go. 1 point. I didn't have it turned on. I turned it off, didn't I? So right, I just need to disconnect the motors. Right, let's disconnect them. Two red ones. Right, so yeah, so if I got light on, we've got basically 0. Let's call it 0. It's 0.8. Hang on, let me just get my torch. There. Wow, how far does that go down? Right, so well, it goes down to, well, it's like 1 volt, isn't it? So let's round it to 1 volt, and then let's cover it up. Have I got the right one? Oh, I've got the wrong one. Right, we cover it up. There's 2.5 volts there, right? So when it's dark, it's got my memory. Right, so so dark is high, and light. Let's put the torch on it again. Yeah, there we go. Right, now when it's when it's got the torch on it, it's 0 volts, and when it's high, dark, we've got our voltage divider voltage, which is pretty much equal to what our voltage divider is. So that there should be equal to the reference volts, well, 2.6. Right, so yeah, we've got the. Oh, what is it when it's dark? Hang on, let me write that down. My memory, I can't even remember that. Oh, where's my memory? Yeah. You might think, how do I manage to get things done? I write it down. Dark. Right, it's dark. What is it? Dark is high, light is low. There we go. Dark is high, light is low. Right, okay. Let's have a look at our circuit again now. And my tea is going cold. I'm going to pause while I drink my tea and have a think. Okay, it's going on forever, isn't it? One moment. Right, add my cup of tea. Now I'm back, and I've also added some text. Because, like I say, my memory is absolutely useless. Well, it's my short-term memory, actually, not my long-term. But anyways. So, I've got dark is high, light is low. Now, I'm using op-amps, but it's what I had in the box. In my box of bits. Really, what I could have used is a comparator, because that's how I'm using the op-amp. I'm just using it as a comparator. And that's another reason for using a NAND gate, because then we've got a threshold for high and low as well. So my NAND gate is doing two jobs basically. It's giving me a digital output for an analog input basically. But if we just view it as a digital comparator, even though it's an op-amp, it works basically. So if this is high, so if it's dark, this is going to be high, and obviously if V plus is greater than a V negative, we're going to get a low out of here. So we've got a low coming in here, and we've got a high coming in here. So what we've got is we've got a low and a high, which is giving us a zero output. And because we've got, what did I say? I just forgot what we were doing. Oh yeah, right. Sorry, my memory is not. I just don't. Short-term memory is useless. Right, so we've got high coming in. So we've got high, and that is greater than this, which gives us a low coming into the low, which gives us, and this one will obviously be guys, just look at what I've written, and basically what happens is at the output we will never get two ons. We'll never get two highs. Basically, that's what I've done it for. Sorry, my memory, but it's the same reason I can't read a book. As soon as I've turned the page, it's gone. It comes back to me about a few hours later, basically, and then I know what I'm doing at the time. Right, so yeah, so we've got our NAND gates, which all this is doing here. Basically, let's put a box around it again for you. So this bit here is our NAND gate. Oh, and that bit up there, that bit, that's the voltage in. It's all them bits. Basically, all it does is it stops us getting too high, two outputs that are both high. So we're not turning both relays on at the same time. That's what I've put that there for, basically. And we've got a little light for the power. And what I'm also doing on this board, right, yes, I digress again, because this is to do with the board. We've already got all this. So let's go back to our little thing. Oh, we don't need that anymore. It's an Owen meter I've got with which has Bluetooth, and it's Bluetooth connects to this, by the way. Uh, where was it? Oh, right, yes. So there's switching these two relays. So I've got it turned on at the moment. Now then, the lighting is going to be a bit rubbish. Now we're going to say, yeah, shit, that's what it is. Because I'm going to use my torch, my torch. I could say I just grab. Hang on, I'll tell you what I was going to do. I was going to say, right, I've just grabbed a bit of sunlight inside my hands and I'm going to shine it. No, I won't. Right, so I've got my torch here, so I'm going to have to turn my other light off, and I'm going to try and get the light in so that right, you can see it working, right? So this is the sunshine coming across. So as the sun shines, it moves it around like that. But the thing is, where's my button? Right, so there is. I didn't want the relays on, both on at night time. So it comes to the end of the day, the sunshine disappears. Now we've got no sodding light there for you to see, have we? Right, hang on. Okay, let's just. This is darkness. That's too bright. Because when I turn my light on again, yeah, hang on. Let me just try and get this light in. Right, fires. Right, can you still see it when I turn it off? No. Oh, you can a bit. Right, so let's just. That was clicked there. Let's try it about there. Right, can you still see it? No, I think we need to be on a brighter bit. How's that? Well, you can, but I like it better than that. Let's try about here. Oh, right, hang on. No, there we go. I'll get it in a minute. Just bear with me. Right, I think that might do it. So when it comes the end of the day, you're right, yeah, you can still see it. Right, I've turned, the sun's gone down, and the sun's going to come up now on the other side. So if I put my torch on, you can see it then turns and follows it, and then as the sun goes around like that, and the sun goes out, and then the sun comes back up again. I think that's just light from the window. It obviously turns back to the light, and then the light will then follow the light again. Right, well, I hope that's enough of that dark. Anyways, let's put the other light back on. There we go. And let's get the lighting fixed. There we go. Now let's try that. Maybe there. That looks better. Right, yes, so what I use is KiCad. And so that's what we've just been looking at in the circuit board. Where are we? Yeah, so there's my circuit. So all hang on. All this wiring here. There's a few resistors, like I say. There's a few resistors, and and these these relays. I'm going to put these on the board with the little transistor, and also there's a flyback diode on there as well. So because we're using a coil, it's got a coil inside. We need a little diode in there to stop any spikes. So if we look here, put a diode on for the spikes. These are our transistors that turn the coil on. Yeah, this is a little diode to show that we've got power. And I'm also going to add this linear voltage regulator for 5 volts, and we can either have that on. We've got the jumper here because that there's connected to. Where's the terminals? There you go. Sorry guys, I've just lost it. I can't see for looking. There's power. Oh, sorry. Yeah, yeah. There's my DC motor. Power comes in. No, sorry. That's my DC motor. They're the terminals that go out to the motor to power the motor, which, like I say, are connected to the common rail. And this is the motor power coming in, which we've got. This will be the positive. Let's put a bit of text in there. Plus. Yeah, so that's one positive. There we go. So that's our positive coming in. Let's light it up as well. So we've got our positive from our power coming in. It goes to the open side of the relay. It lights a little diode to say we've got power there as well. I put a yellow one in there. And then I've put this jumper in so we can solder that. So if our motor power is less than, I think, 32 volts, we can actually power this linear regulator. The max that can go in here is about 30 odd volts. So as long as the motor power is less than 30 volts, we can use this linear regulator to power the rest of the circuit. And that way we only need one power source. If you're going to use a motor, say like 50 volts or 60 volts, actually I don't think they go up as high as that. Where's the... Hang about. Right, hang on. What did it say? Oh damn, I keep clicking on the wrong thing. Right, let's bring that back again. Right, so where's that sheet? Right, yeah, so there's the data sheet for the motors. Oh, so we can, it says 10 amps, 28 volt DC. But obviously if you're only using maybe a 2 amp motor, you can probably go up with your voltage a touch. I mean, if you just work that out to sort of like get a wattage or something of the motor, you know. Yeah, suit yourself. Or you can replace the relays with whatever relay. If you want some big chunky motor that's bigger, you can just swap out these relays for a bigger motor. But for this, the other runs on 5 volts. If you're not using this jumper here, so you've got a motor that's more than 30 odd volts, then you can put 5 volts in on this input here, this VCC there on pin 2, and that will 5 volts on there will power the circuit here. Yes, so that's it. And I've got 2 little LEDs that tell you which servo's on as well. So these light up when these are activated. So what we do, I've done with that, is let's just minimize that and bring up the circuit board. Oh, let me get rid of that as well. I've highlighted that, so there we go. Turn that off. Yeah, so this is the circuit board. I've put the 2 chips on. I've put my socket there. And like I say, you can have onboard LDRs, or you can wire in LDRs to these 2 inputs here, basically. What we'll do is, well, you can't really see much there, so let's have a look at the 3D view. Bring that in. Oh, let me just, I don't like maximize everything. Yeah, so yeah, that's it there. So this is what it's going to look like. So we've got our onboard LDRs there, 2 relays. This is our NAND gate chip, and this is our op-amp chip. This is where the motor goes in, so you put your two terminals in for your motor, and this is where the power goes in for the motor, and this is is for plugging in remote LDRs, or also putting 5 volts in if needed. And then what we've got here is we've got the solder jumpers for the LDRs. That's if you want to use the onboard LDRs, you just solder these two together. And if you want to power off the motor power, you just solder this up, and it will then power that linear regulator to give 5 volts to everything. Yeah, that's it. And so what I'm going to do, the quick and easiest way is, if I go to, not that one, let's get rid of that then, get rid of that. This one here, I've got this little icon here, and if I just bring my, this is my web browser, and I just go click on PCBWay here now, I can just click that. Let me just bring that back. And it takes me straight to PCBWay. And there, everything's done. It was just one click of that button, and you can see there that my PCB has been loaded up. And that needs to go to UK. I'm in the UK, guys. Oh, there we go. United Kingdom. And look for the cheapest. Well, there's global economy. You know, I mean, 8 to 10 business days. I can wait that long, mate. I don't need it really that quick. And you just apply that. Look at that, brings that board down to 8 dot. Oh, and also, where are we? Here. Yeah, it says 5 pieces. Let's just go 10 pieces. Well, it's 8. It's what was it? 10 pence more. 10 pence more for doubling up the amount for 10 pieces. So you know, you can't go wrong, can you? And now, what I tend to do these days also, I like the blue. So the blue background, and this is white. I wonder if yellow's. I wonder what yellow's like. I wonder if it's any dearer. Oh yeah. Oh, we don't want yellow. That knocks it up to 42. So we'll stick with white. I haven't tried the black one yet. I wonder if that's. Oh, that's available at the same price as well. So we can do that. I think. What about a red one? No, I'll stick with blue. I like blue. Blue's nice, and white. Now, if you want, also, what you can do, if you're going to make this all, you can order a stencil on top of that as well. But I don't need this. I make my own, so I'll do that in another video maybe. And there's an assembly service, so you know, you can ask them to assemble it and put all the parts on as well. So I don't need all that. I'm going to make it myself, but that's what's going to happen. And I just save it to my cart, and what they'll do is they will do a review. So I'll just save that. Yeah, and that's in my cart. Oh, am I not signed in? Right. Well, I'm going to sign in. I hope this doesn't do anything that. There we go. We're at that point. So what they will do is review it and say that it's okay, and then what you do is you say okay. Like I say, you've got under review here. So once it's been reviewed, to make sure that you've done nothing silly, they'll come back with either a question or say it's okay, and then what you do is you then click order. Right, I'll leave that at that. Don't need that anymore. And I suppose just to end the video, it's been a bit of a long, boring video, hasn't it, really? Anyways, if you've made it to the end, thanks for watching. You know what I tend to do is ramble about. So it is my light source again, and I'll turn this other one off, and there you can see it working as the light, imagine this torch being the sun going round, and it just follows it and keeps it lined up with the sun, basically. Or any light source. Well, it's going to be the sun, isn't it? So yeah, I hope you like that. And like I say, it's just made with this this little op amp, and that's all. Op amp, these two relays basically, that's controlling that. There's no Arduino or microcontroller doing anything. It's all pretty much linear. It goes digital when it goes through the NOR gate. There we go. When it goes through the NOR gates, it goes digital then. But until then, it's pretty much linear. So depending. Oh, and what I forgot to mention, you can actually put. You may want to put sort of like a cone round these sensors, and you know, by putting cones around, I'll go into that maybe once I've got the PCB and do the second bit. But hang about, let me just turn the light back on. There. So yeah, what can I say? I hope you found it interesting, and I'll stop it at that.